Thank you very much. Thank you for giving me the opportunity to present here in the aeronautical seminar. My presentation is Future Airborne EW, Enhancing Capabilities through Operational and Functional Convergence. The outline of the presentation will be evolution of EW threats, impact on operational requirements, impact of the EW system requirement, enhancing on EW capability, convergence of separate EW functionality. Later on, I will discuss the technological aspects and summary. Evolution of the requirements. If we will see the EW battlefield, we can see that before few years, it's come from loosely coupled weapon system that transmit in single mode radar, static in location and electronic magnetic parameters. The parameter of this radar changed to integrated air defense network. In the past, there was 3 modes of radar: search, acquisition, lock, and guidance. Not all the same radar do all these modes. Sometimes there was search radar, and sometimes there was acquisition and log and guidance radars. From EW point of view, also the EW system don't deal in all the modes of the radars. Usually, standoff jammer deal with the search radars, and self-protection deal with the acquisition and lock radars. Today, we are speaking on integrated air defense network. The radars become dynamic in the location. They are mobile. Each radar can move from location to location in few minutes. They are highly agile radar that can change the parameter on the frequency and the PRI in the pulse width. There is a multi-mode radar that one radar do and jump from all the modes that I described. There are low probability of intercept radars that can transmit just 1 pulse in a second. And there is also communication, command, and control networks that we need to deal in that, because the radars today working in network. It means that one radar can send a target to another radar by a networking. All this changing in the arena has impact on the operational requirement. In order to deal with this requirement, we need to handle weapon system as a whole. It means communication and control, search, acquisition, track, guide, and seek radar can taken as a whole. We should handle air defense system as a whole, early warning, communication, surface-to-air missiles. We should handle spectrum as a whole, VHF, UHF, RF, millimeter wave, and IR. We should improve the probability of intercept in order to shorten the time. We should reduce the dependence on the pre-flight message by the electronic parameters, by the location of the emitters. We should support the isolated aircraft in a hostile environment, and we should close loop in the platform. It means that the platform should detect, jam, and destroy, and should calculate also the location of the emitter. All these operational requirements are related to all the platform, to fighter, rotary wing, and UAV. We can see from any enemy point of view convergence in the requirement. We are not speaking today in a single platform engagement. It is not complete of many of single. It's not a war of aircraft to aircraft, or aircraft to SAM radar, or aircraft to IR missile. It is a war comprised of many interrelated battles. The enemy spreads the various levels. He spread it in the range, in the spectral region, in the sensors. He integrates all this level. If using the information, disseminating the data, and each other is complementing the behavior of the other. The means of to deal of this fight war is to recognize the integration and to give answer for this integration. Convergence of the requirement and the functionalities into a single system. Today, it's not just a single system. It's a different system and different requirement. If we will take all the platforms, there is the RWR system with its requirement, there is ECM system with its requirement, there is ESM, a lean system with a requirement, MWS with a requirement, and I'm not sure that there is a link between the requirement of each other. Also, the department that defines this requirement is different department. There is a command and operation, there is R&D effort, there is procurement, and there is no link between all this effort. From industrial point of view, also in our part, there is a department of MWS, ESM, ECM. I'm not sure that we are transferring information between all the departments in order to do a better requirement and better solution to the customer. The user, customer, and provider must mutually adapt this. A mindset, structure, and operation for Convergence, the EW solution to take form. If we will take, for example, the commercial market, we can see that, let's take Apple, that start with a song provider, the iPod. Later on, they add the camera. Later on, they add to this iPod the internet. At the end, it becomes the iPhone that everybody is using. So we add a lot of performance to a single, let's say, LRU, in order to give the customer more solution in a single LRU. How it's impacting the EW system. Convergence of RWR and ESM. I will define in each one the operational requirement and then the functional and technical aspects. The operational requirement of this convergence is to provide update location information and to provide updated link data. In order to do that, first the RWR and ESM is deal with the same threats. We should increase the focus on search radar. We should calculate geolocation. We should collect and record all the data. We should increase the receiver load. We should have a robust arena handling, and we should have operational support tools. If in the past, for a lean ESM system, we use a big aircraft, today there is no difference between the lean system or ECM system to the self-protection that is installed in the UAV or in fighter from performance point of view. Convergence of RWR and ECM. The operational requirement is to receive and jam at the same time or to jam without affecting the receiving. To handle all the threats from receiving point of view, from jamming point of view. To have internal installation in order not to affect the performance of the aircraft. And to provide the pilot and the programmer a unified picture and a unified control. In order to do that, we should support ECM requirement without compromising the RWR. It means that when we are jamming, we can't affect the receiving. We should deal with high duty cycle transmission without affecting the receiving of the RWR. We should optimize the resources. It means that to use the same receiver for the RWR and the same receiver for the ECM. We should minimize the blank loose-through between these two issues of receiving and transmitting, and we should support a DRFM. From aircraft and installation point of view, we should share the aircraft aperture. It means in the aircraft there is RWR system, RWR antenna. We can use the same antenna in order to receive also for the ECM. Since the arena is changed, also the spectral of the arena is changed. Now we are discussing and dealing with low band and millimeter wave handling. There are radar in the arena that are transmitting in the low band. There are radar in the arena that are transmitting also in the millimeter wave. So if till today the system deals with usually between 2 to 18 gigahertz, we should now discuss to handle 0.1 gigahertz to 40 gigahertz. Especially using the VHF. You know that in the arena in the next few years we'll have a special fighters that will be stealths. In order to detect them, I believe that VHF will detect them better than high frequency. So this is the reason that we need to handle also this frequency. And the functional and the technical aspect for handling the low band and the millimeter wave, first, in order to handle the millimeter wave, we had to add at least 4 small antennas to the aircraft. And we should use a down converter that converts the 18 to 40 gigahertz to regular band of 2 to 80 gigahertz. In order to handle the low band, we should install appropriate antenna into the aircraft. We should directly digital receiving all this data, since we have usually today digital receiver and all the receivers who can directly sample this low frequency, and we should receive and jam side lobe and search. There are a lot of aircraft, especially helicopters, that use also millimeter wave missile warning system. There are IR or other method. The operational requirement here is to unify the threat picture file between the RWR and the MWS in order to use the queuing of the sensors. In order to do it and to put it into the same system, we should miniaturize and simplify the IR processing, where will be at the end centralized fusion of the data. Communication handling. A lot of radars using network handling in order to transfer data between one battle to another battle. This means short engagement by SAM and deny target handoff. There are ground-to-air and air-to-air communication. We need to disrupt control and corruption. We need to disrupt munition and guiding. The functional and technical aspect for this is to use a unified system that can jam the communication and also the radar. We should define and allocate necessary antenna for this low band. We should receive and transmit high ARP in order to jam these radars. Network operation. My colleague, Dr. Andrea, presents the networking of the system. So since we have a lot of platform here, we have UAVs, we have fighters, we have helicopters, we have a ground system. Each system can detect and see another things. If we will share a data, we will have a better picture. If each system sees the same data, we can share a data in order to improve the performance. Here the operational requirement is to force multipliers and improve the POI, probability of intercept. To force multiplier and improve the ECM, it means to use synchronized jamming or something like that. To shorten the time for geolocation. And to have a unified picture to the pilot by data dissemination. In order to do that, we need a link that the same link will be used for all the aircraft. The EW system should have access to this link. We should have a bandwidth to this link and small latency in order to give a better performance. We should receive and transmit load. We should fuse the data and localize. By doing that, we can increase the sensitivity and dealing with side lobe. Can it be done? I will start to describe what the technology today allowed us. Today, most of the system has digital receiver. There are two different digital receivers. One bit digital receiver that can cover the full spectrum from 0 to 40 gigahertz, and we have multi-bit digital receiver that can cover a few gigahertz, and I believe in the future it will cover more and more bandwidths. We have transmitters, few kinds of transmitter, MPM, miniaturized MPM transmitters, and solid-state phased array transmitters that use two different technologies, gallium nitride and gallium arsenide. We have RF capability, MEMIC, RFIC, in order to miniaturize all the receiver part of the system. We have advanced ECM, which means robust techniques in order to jam the emitters. We can do geolocation by precise method and using the existing antenna of the aircraft, not by adding different antenna, by existing antenna. And we have, of course, data processing, and we can see here from the commercial industry that this processing is doubled every few years, and it helps us to develop and use different and better algorithms. In the interfaces of sharing data between the MFD and the system, or between the system, we have a lot of interfaces, high-speed interfaces. I will give here a few examples of system, or this is system of Elisa system. Elisa developed in the last 2 years unified systems that unified RWR, ESM, and ECM. The system has wideband receiver that can see all the RNA at the same time from 2 to 18 gigahertz. We are using several receiving systems in order to receive and calculate localization for the emitters, and we are using also several channels to transmit and jam. We have advanced techniques generation capability. We have multi-gigabyte recording facility. This means that we can record most of all the data that the system receives in order to analyze it offline. We have robust and quickly adaptive arena handling. We have accurate geolocation by using the existing antenna of the aircraft and doing localization by measuring the phase. We have multi-platform operation via data link, and all this come into one LRU. I believe in the future the size of the LRU and the performance of the LRU will be better, and we can add more performance to this LRU. From power amplifier point of view, we can do 6 to 18 power amplifier based on solid-state power transmitters. For example, 60 elements give you 60 dBm. If I will compare it to the to existing TWT, usually TWT give between 50 to 55 dBm, or it's limited in duty cycle for 60 dBm. So this will solve all the ERP problem. Since we are using different systems and different platforms, like UAV and helicopters, we can't put a bigger system because of the limitation of the weight. So there is also lightweight self-protection system that manage a suite control, RWR, ESM, integrated chaff flare controller, integrated laser warning receiver, and integration with the MWS. In the IR, we start to miniaturize the IR controller to 2 cards in order to allow us in the future to put it in the same LRU like the RWR and ECM. And we can see that from year to year, the technology is improving and it allowed us to put more performance in the same LRU. From the ComJam, we start to develop a card that do all the ComJam, and in order to allow us to put it into this LRU. If we will see the evolution of the threat, the requirement, and the solution, we can see that from threat point of view, we start to deal at the beginning with 1 or 2 threads, low duty cycle, lock-on, static. Later on, we come to deal with many threats, high duty cycle, in search mode. And today we are speaking about the integrated threats, networking, dynamic and agile in the location and the parameters, LPI threats. From requirement point of view, the evolution was, in the beginning we start self-protection that receive and jam mostly local emitters. Later on, the self-protection deal with search emitters, situational awareness, and now we are speaking about self-protection that will have force protection. It's multispectral, cover all the spectrum between 0.1 to 40 gigahertz. It should have a targeting, and it should be robust. From the solution point of view, we start in the beginning before a lot of years with crystal video or IFM with limited performance. Later on, we moved to super heterodyne systems with DRFM and using delta T-Roy interferometer. And today we are speaking about panoramic receiver using MEMICs, multi-beam array transmitters, calculating localization, unified system of RWR, ESM, ECM, MWS, and ComGen, and networking all the system together. To summarize, the EWW battlefield is involving operational and technological aspects. The modern battlefield required a multi-phase solution, converges of previously separate requirements to functionalities into one system. Shifting the converged solution required change in the mindset, in the fighter, in the support, in the operational, and in the industry. A comprehensive solution of the EW system should cover full spectrum, unified RWR, ECM, ESM, ELINT, calculating geolocation, integrated MWS, chaff flare, and laser warning, data fusion, networking operation, and robust and adaptive. We can see that some of this performance we have today. I believe in the next 5 to 10 years, we'll have all the performance because the technology is moving to that. Thank you.